Hello everyone. In the last lecture, we discussed the torque slip characteristic of induction machine. In this lecture, we will going to discuss the effect of rotor resistance on the speed torque characteristic of the induction machine. So, before going to this topic, I will discuss a little bit about the torque slip characteristic once again. So, the torque slip characteristic previously studied is having the curve shape like this. So there is two regions there and discussed in last lecture. One is stable region, the other one is unstable region. So we talk about the torque speed or torque slip characteristic. Here it is shown, the curve is shown between torque and speed, but the same curve can be shown with slip and torque also, where and the speed is 0 is having slip equal to 1, whereas the value of n is equal to ns at rotor speed equal to synchronous speed, the slip becomes 0. So this speed is showing the slip 0 region. The slip is varying from a synchronous speed to 0 speed. So if we talk about in terms of torque, this torque shows starting torque and about this value of the torque is known as full load torque, and this torque is known as maximum torque. So this is all about the previous lecture we studied. Now moving again forward, moving to the next slide, we can conclude from the previous slide that there is some certain value of torque. We can define it as full load torque. If the full load torque or the maximum value of torque, we can better to write it as some predefined value of the torque. If the load torque is greater than this electromagnetic torque, the machine stops rotating or stalls. So load torque should be less than electromagnetic torque. Now if we discuss in the previous slide, we discussed about the lower slip region and the higher slip region. So if so, let us define some critical value of s denoted by this value. This we can say critical value of slip. So it is a boundary between high slip region and low slip region. So let us say that for very low value of slip, the torque slip characteristic is linear, or we can say it is as very steepy slope is very steepy. So whereas for the high slip region, the torque value, the curve is having a gradual slope, not a steep slope. So this is discussed in this slide. Now moving forward, how the torque slip characteristic is affected by the rotor resistance. So the value of stalling torque may be obtained by differentiating the expression of electromagnetic torque with respect to 0 and setting it to 0 with respect to slip. So if we differentiate the torque expression with respect to resistance, then the value comes out to be, we can get we have to differentiate the torque expression with respect to rotor resistance and putting the value equal to 0. Setting it 0, we will find the value of slip, critical value of slip. So the critical value of slip comes out to be like this expression and this expression of the electromagnetic torque. So we can conclude from this expression that the critical value of torque is independent of r dash, while the critical value of slip is directly proportional to r dash. Yes, we can see here, in this expression the slip is depending upon r dash, whereas the torque not depending on the resistance, critical value of resistance. So this shows that by varying the slip, the maximum value of torque, is remains unchanged. It remains unchanged. Therefore we can easily therefore this expression shows that maximum torque remains unchanged, whereas the torque slip characteristic shifts. We can change the by changing the slip we can change the torque slip characteristic. So the resistance value can be varied to change the starting torque also, whereas maximum torque remains fixed. So if rr dash is chosen equal to under root of r square plus xls plus xlr dash, then the expression for the slip becomes unity, means both denominator and numerator get cancelled and s becomes equal to 1. But this value is when the slip becomes 1 when the n is 0 or starting value of the machine, so starting torque. So if we increase the rotor resistance value such that it becomes equal to this expression, the above expression shown, means rr dash is equal to this value, then slip becomes 1 and the starting torque we get the maximum value of the torque. This is shown by the torque slip characteristic here. So by increasing the rotor resistance value, this is rotor resistance, let us consider as 1, rotor resistance considered as 2, rotor resistance considered as 3. Here the R1 is less than R2 is less than R3, and we can see that the curve is shifting as the resistance value is increasing, and at some critical time we get the maximum value of torque at the starting only. So this is all about the how we can change the value of rotor resistance and we can increase the value of torque, starting torque, and we can get the maximum starting torque at the starting without changing the value of maximum torque. We can see that here maximum torque remains same, it is not changing, because in the expression of maximum torque we found that maximum torque is not depending on the resistance, it is constant, but the starting torque can be changed. So maximum torque remains same and the starting torque becomes maximum torque at the value of critical resistance. Thank you. That's all about this lecture. We will discuss next topic in the next lecture. Thank you. Take care.